Hello, I'm Peter Schaknat, Managing Director at Schaknat Electronen GmbH. Today we are optimizing a Scania R650. Very briefly about today's procedure as well. This is a Scania R650 with a DC16 V8 engine delivering 3,300 Newton meters of original torque and a displacement of 16.4 liters. Among the 520, 580 and 650 variants, this is the most powerful version in this engine generation. It is a Euro 6C engine with OptiCruise and a TMS2 transmission. The customer recently complained that the truck does not pull very well and also consumes quite a lot of fuel. So today we will also be running a diagnostic on it. Hard fun. Now we'll do an initial measurement and take a look at the peak performance to see where it actually stands. You know yourselves, we always have trucks where customers complain that the performance just isn't quite right, the fuel consumption isn't exactly right, or they just don't shift properly or smoothly. That's just how it is. You know, for example, when you if you line up 10 of the same model side by side, each one is different. So not every truck always has the same performance. And that's why, as I said, we'll take a look at it today. That's why we do the initial measurement. If we notice anything in the diagram that doesn't fit, if the torque values aren't right, we'll adjust that separately again. And yes, as I said, let's just take a look at the initial measurement now. We'll also flash it again with the app. I can upload the data set for the customer online, but I can only do that once I've seen the initial measurement. Regarding the software version, so I'd say let's get started. I've already secured the truck. Front off again, back off again. We're measuring 4WD again. It's always very important to measure in all-wheel drive. We're powering the front axle again using hydraulics, simply so we have the road simulation again. It's always important to have values you can actually work with, how it actually runs on the road. We're measuring by engine speed again, from top to bottom, just as we did before. This method allows us to carefully observe how the engine speed changes at every stage, making it possible to analyze the customer's problem in detail and make the necessary adjustments. You can see the results of this process back here. That's the drive axle, which is connected to the eddy current brake, allowing us to simulate different conditions for a more accurate analysis. As I said, V8 engines have exceptionally strong torque. That's why we always go ahead and press it into the rollers with 3 to 4 tons to ensure maximum grip so that we really have 100% traction. Simply at the tire. What's more important when warming up the tires is that the wheel doesn't spin, that it doesn't slip on the rollers. Then I'd say let's start with the initial measurement. We're starting the measurement now. Earlier I went ahead and deactivated the top speed limiter again because it's important to me that we measure the scanner with the speed limiter off. Alright, let's also turn off the traction control here. Okay, distance temperature. Lane change assistant, important. Always turn everything off so that nothing interferes electronically. I'm just going to warm up the tires a bit now, but I already did that a little earlier so that we don't distort the engine temperature readings. And then let's rev it up now. We're measuring again in 11th gear, because in this model that's the direct gear again. That way we have direct power transmission from the engine to the drivetrain at the rear. That also gives us the most accurate measurement results. You often have that with other trucks too if I can't increase the top speed. There are some truck manufacturers like Iveco, for example. If they have top torque, we can't disable the speed limiter. In those cases, we have to measure in lower gears and really have to add about 200 Newton meters as a factor if the torque increase is present in the higher gears. So now at this point, I will proceed forward and carefully do the axle alignment at 1000 revolutions. Alright, let's do that here. Exactly, there we have the 1000. Right, good. I just explained it already. We'll do it again. I'll brake it at the bottom, then run it up from low to high, disengage the clutch at the top, measure the torque using the high-load technique, and measure the power loss during coasting. Of course, it's also important here to switch off all retarders so that we don't get any distortion in the results during the coasting phase. Then we'll brake it. Now you can already hear the turbo just a little bit softly whistling as it gradually builds up more torque. Then we start the measurement. Now you can really hear the turbo whistling. Now you can see the RPM and the speed right here currently. We run it all the way up to 2,200. And then we disengage the clutch. Now we can see right up here on the screen 642 horsepower and 3,406 Newton meters of torque. Originally it was supposed to have 3,300 Newton meters and 650 horsepower, so it's actually 100 Newton meters stronger. Okay, it has 8 horsepower less. So we're going to do 2 more measurements now so that we have reference values. But in terms of torque, because the customer said it doesn't really pull in terms of power or is very sluggish in the mountains. As I said, you can't see it from the torque, but now we're going to step outside for a moment. I'll show you the curve up front because I already see a small error in it. We'll take care of that quickly outside now, and then I'll explain something about it. And after that, we'll program the IQB right away. So you can see it again here at the top of the measurement. I can show you this again here. You can see the RPM down here. The lower curve is the torque. Here you can see 1,000 to 2,200 revolutions. The customer complained that when he drives into the mountain, he has to downshift relatively quickly. You can see it holds the torque from 1,150 to 1,350, and then it already drops off again at the top. And I think that's what the customer is complaining about. It only has a very short rev range where it reaches its maximum torque. And when I drive into a mountain, and if the engine isn't elastic enough and the torque drops off again too quickly, then the transmission experiences a torque drop. It then automatically starts to downshift. We will try to raise the entire torque band, but also to maintain it for a longer period of time so that the torque output remains more elastic and flexible. You can actually see this quite well with Volvo. They always have the maximum torque constant from 1,000 to 1,500 RPM. Every manufacturer does it a little differently. You can clearly see, compared to other Scania 650s that we've already measured today, it's the same there too. After the update, not every engine is exactly the same as before. The torque curves are now a bit different in some areas compared to before. But as I said, we can adjust that perfectly. That's why the initial measurements are so useful. When I have the facts, I can build on them, and then I can program it individually for the customer. So, as I said, I'm going to the PC now. I'll program that, upload it online to the server, and then we'll flash it with the app. So, as I said, I'll aim for a complete increase. I'll set it to a maximum of about 350 Newton meters. But I'll try to keep it high at the end because, as I said, the customer keeps the cars for quite a long time. So, as I said, I don't want to have any excess power now. I just want it to be responsive, to have smooth shifting again, and for it to be fuel efficient. That's simply the main thing at the moment. The most important thing is simply the fuel consumption. The customer has 2 trucks, so 2 identical 650s. And he said that one of them already uses 3 liters less from the factory, and that will probably already explain our problem. If I were to measure the other truck, it would probably already have a broader torque range from the factory. So now program the truck, upload it, and then we'll flash it right away with the app. As I said, I've now programmed it on the PC and looked over the data again. I tried to keep the torque curve nice and broad, making sure it stays consistent. We now also need to end up somewhere between approximately 780 and 800 horsepower, provided that the engine is technically sound. Afterwards, I will thoroughly check the engine again, both inside and out, during the measurement process anyway. I'll also run high-pressure diagnostic tests again and recalibrate the fuel injectors to make sure that everything is really, truly technically in order. Because I know myself, if the fuel pressure isn't right, or the boost pressure isn't right, or the injector isn't working properly, if it's not running 100%, then you'll quickly end up with increased consumption. Or for example, if the NOx sensors have issues, that's now also factored in with the new emission standards. All of that contributes to increased consumption. It's always been like that. Plug the OBD flasher back into the OBD port here. Then you'll see it illuminates with a green light. Bluetooth is active again. So then I go back, select the scanner again, and reconnect it to the dongle. So then I go back into the app. You can see it reconnects automatically. Then I go back to the driving data streams here. I enter the license plate and customer info again. So Scania R650. All right. Now here at the engine control unit, you can see a software version here. This is an older software version. Then we have the stock state again, eco optimization, power optimization. We installed both of them. But we're flashing the eco optimization because in this case it's really about fuel consumption. Then we'll flash it right away. I've said it many times before, and I want to emphasize it again. Always the same thing. Do not walk away from the truck under any circumstances. When you are flashing, you really should not take phone calls at all. The Bluetooth connection must absolutely not be interrupted. It's extremely important that we do not introduce any kind of error during this process. That was the eBlue system you heard. The eBlue pump, it's running. If you look at the customer, as I said, at the app, we will be building that soon. You can store multiple software versions. For example, you can also include it for display purposes. Or if the customer wants to install any interchangeable flaps or other things, we will do so in the future as we will have more options to incorporate these things. Now you see he has finished programming, he says. Okay again. So then we go back again. So transmission optimization, we heard it again, click, click, he did that as well. Perfect, then he already did that. As I said, now we'll go ahead and do the baseline measurement. Afterwards, though, I would still check the car again because the customer said he has two identical cars, but they're so different when it comes to fuel consumption that maybe we'll find some other fault, so we can rule that out as well. Everything related to trucks, from diagnostics to electrics, we're pretty good at that too because we optimize a lot of trucks and get to know the customer's problems as well. And because of that, in terms of know-how and knowledge, we don't know everything. Of course, when it comes to issues with performance, fuel, or transmission, people always call us anyway. We actually almost always find a solution for that. All right then, let's do the baseline measurement and see what comes out of it. We've now done the baseline measurement. Afterwards, I read out the entire truck again. I did everything again. I reset everything again, including the injector adaptation and the transmission. I also checked the learning values again, since the engines sometimes have issues there. Or in general, since this isn't the next generation, it's the loud air temperature sensor. It has voltage fluctuations which cause it to display different temperatures. And that could also be the reason why you're experiencing power fluctuations in the mountains. But everything fits so far. I couldn't find any real fault, but it's always good to retrain the systems anyway. I'm starting now with the baseline measurement, just beginning. It's actually perfect, just the way I imagined it. I'm starting it here. We now have 775 horsepower output and just under 3,685 Newton meters of torque. I always say, for a 6.5 liter engine like this, I think the optimal setting is at 3,700 Newton meters, so 400 Newton meters more and 750 horsepower. That's actually perfect for it. But you can also see it on our other charts. What we often see these days is that the engines have quite a bit of variation depending on the software versions. But as I said, I think it's perfect like this. You can see it too. Now it holds the maximum torque, almost up to 1,600 RPM, whereas before it would already drop off at 1,200, 1,300, or even 1,250, 1,300 RPM. I think that if the customer says, for example, drive it straight, take it into the mountains and let it come back down, then it will hold for an extremely long time. The torque, you don't start off too early simply so that the engine, through the water pump, oil pump simply has the necessary cooling as well. It's also very important not to apply too much torque too early because that can actually damage the engines. But as you can see, it's nice and flexible, and let's take a look at the curve. Towards the maximum RPM, we return to the stock range so that we can't over-rev the engine or make absolutely sure we don't break anything by overspinning it. So, as I said, I'm really extremely satisfied with the result. This is exactly how I imagined it, and that's how I programmed it as well. The adaptation isn't always the same, depending on how the trucks respond, but as you can see, I wanted it to be close. We have 3,700 Newton meters, just 15 Newton meters short. That's pretty much optimal as far as I'm concerned. As I said, we've now reached the end of the video. I'm really super satisfied with the result. As I said, I think the customer got exactly what he wanted. He'll also get the app from me as well. Of course, I'll also put an air freshener in for him, just like every customer who comes to the test bench here. He'll get a Hugo Boss air freshener from our company. If the customer ever needs a different software, that would be very easy for us too. I could simply provide it to him online without any hassle. In the app, there would just be another button, so he could simply click one more button. As I already mentioned regarding the adjustment, I think I'll talk to the customer about it later, and I estimate about 3 to 4 liters. We'll definitely be able to save that much. Because this torque issue, the RPM issue that I had, which he also described to me, especially going up the hill, I tried to address that with this. That way I also don't have to downshift the transmission as often with the whole setup. So I think we've achieved exactly what he wanted. I'll talk to him in 2 or 3 weeks to see if he's satisfied with it. The customer has had several trucks optimized by us and has always been satisfied so far. That's why we're also his first point of contact when it comes to things like this. He also has nice trucks, and he's personally interested in the truck performance test bench. That's why, as I said, it's a beautiful vehicle. Red isn't really my color, but I still think it's really great. As I said, if you're interested in this topic, check out our video about the Scania R650 engine and transmission optimization. Feel free to visit our website at www.schaknat.de. You can also give us a call, send us an email, or contact us via WhatsApp. We're also happy to provide advice over the phone. That might actually be easier, since there are a lot of individual, specific questions. For example, about larger fleets and so on. My brother Peter, myself, or my colleagues are happy to give you personalized advice. As I said, I'm glad you tuned into our video again. That's it. Feel free to comment below the posts about what you'd like to see next time, or what should be improved or changed in the videos. As I said, thank you very much. See you next time. Bye.